Good morning, student. Today we are going to learn about channel length modulation. So, as we know, modulation means change in parameter. So here it refers to the change in length of channel. Channel length modulation happens when MOSFET operates in saturation region. How the length of channel has changed. If we increase the drain to source voltage in saturation region, means increase more than drain saturation voltage, that is VDSAT, we observe that there is a decrease in channel length. So channel length will change with respect to drain voltage of MOSFET. First we consider the charge density in channel, that is Q of Y equal to minus Cox into VGS minus VC of Y minus VT0. So Cox is the oxide capacitance, VGS is the gate to source voltage, VC of Y is the channel voltage, VT0 is the minimum voltage required to form a channel, and minus is given due to the charge of electron that responsible for the current flow. Next, let's see the diagram. In the gradual channel approximation, we discuss about the coordinate system of the structure, where x-axis is perpendicular to the surface and y-axis is parallel to the surface, where y equal to 0 means the origin point is near the source end and the source terminal is set to 0 volt. Because of that, at y equal to 0, the channel voltage is 0. So inversion layer charge at source y equal to 0 and is given by Q of y equal to 0 equal to minus Cox into VGS minus VT0. The VC of y at y equal to 0 is 0. Because of that, this term is not mentioned here. Next, as we know, the channel length is L. So when y equal to L, then that point is near the drain end and the drain terminal is set to a voltage, that is VDS. Because of that, we consider the channel voltage at y equal to L is VDS. So here the VC of y value is mentioned as VDS. Because of that, the inversion layer charge at drain end y equal to L is given by Q of y equal to minus Cox into VGS minus VDS minus VT0. Next, at the edge of saturation, VDS equal to VDSAT, that is when the channel touch the surface. That point is known as pinch off point and the voltage is known as saturation voltage. So when VDS equal to VDSAT means drain voltage, at that time what happened? The difference between gate terminal and drain terminal is equal to VT0, means VGS minus VDS equal to VT0. So here the VDS value is equal to VDSAT equal to VGS minus VT0. Then the inversion layer charge at drain end y equal to L in saturation region is given by Q of y equal to L equal to 0, means here see, as the channel touch the surface means at this point there is no channel present near the drain surface. As there is no channel present means the channel voltage near the drain terminal is equal to 0, means channel voltage is equal to 0 as there is no channel, there is no electron present. Because of that, the charge density near the drain end is equal to 0, means when y equal to L, as the length of the channel is L. So here it is Q of y equal to L equal to 0. Next, if we further increase drain voltage beyond this saturation voltage, then length of channel will decrease to L dash. So in the second diagram we can see, if the drain to source voltage VDS is increased further beyond the saturation voltage, so that VDS greater than VDSAT, an even larger portion of the channel becomes pinched off, and then length of channel will decrease to L dash, means larger portion is pinched off and the length of the channel will decrease to L dash, means previously the channel length is 0 to L, means up to this point, but as we increase the drain to source voltage beyond VDSAT, the channel starts to decrease, and right now the channel length is L dash, and the change in length we considered it as delta L. So effective channel length means at this point what is the channel length, as this one is the channel. If we try to find out the length of the channel, then right now the channel length is L dash equal to, previously the channel length is L, then minus delta L, means the change in length, that is delta L. So L dash equal to L minus delta L. Then we get our new channel length, that is known as effective channel length. Here it is L dash equal to L minus delta L, where delta L is the length of the channel segment with charge density Q of y equal to 0. Hence, the pinch off point moves from the drain end of the channel towards the source with increasing drain to source voltage, and the channel voltage at the pinch off point remains equal to VDSAT. So the gradual channel approximation is valid in the remaining channel region. Thus, the drain current in saturation region is given by ID sat equal to mu n Cox by 2 into W by L dash, means in gradual channel approximation the channel length is L, but here in channel length modulation the channel length is considered as L dash. Because of that, here we write L dash, except that all terms are same. So mu n Cox by 2 into W by L dash into VGS minus VT0 whole square. Then already we know the value of L dash, that is L minus delta L. So here we substitute the value of L dash. Next we take the L common. Because of that we get this term 1 minus delta L by L. So the equation is ID sat equal to 1 by 1 minus delta L by L into mu n Cox by 2 into W by L into VGS minus VT0 whole square. Here delta L is directly proportional to the square root of VDS minus VDSAT. Then to simplify this drain current equation, we will take 1 minus delta L by L equal to 1 minus lambda VDS. Lambda is the channel length modulation coefficient. So in the next equation we substitute this value with this 1 minus lambda VDS. So here we substitute the value 1 minus delta L by L with this 1 minus lambda BTS. Next, to simplify the equation, we multiply 1 plus, to simplify equation, we multiply the 1 plus lambda BDS in numerator and denominator. Here we can see we multiply the value 1 plus lambda BDS in the numerator and the denominator. As we know, 1 minus b into 1 plus b equal to 1 square minus b square. So we use this formula and here we write this value. Okay, then we assume lambda BDS is lesser than 1. Because of that, we neglect this term, and finally we get ID SAT value, that is mu n Cox by 2 into W by L into BGS minus VT0 whole square into 1 plus lambda VDS. So this is the equation in channel length modulation. Next is the VI characteristic. Here this characteristic curve is between drain current and drain voltage. Here we can see different curves. These curves are because of different values of BGS, and this region is linear region and this region is saturation region. Where we see the straight line means ID current is constant, that region is created or drawn by neglecting channel length modulation coefficient, that is lambda, means we consider here lambda equal to 0, and where we can see the slope portion, there we consider the value of lambda, that is channel length modulation coefficient lambda is not equal to 0. So in channel length modulation, the saturation mode drain current increases linearly with VDS instead of remain constant in gradual channel approximation method. The slope of the current voltage curve in the saturation region is determined by the channel length modulation coefficient, that is lambda. So this is all about today's class. Thank you.